on practice problem number 3. First thing it's asking us is a ball is dropped from rest near Earth. Neglect air resistance. Justify all answers thoroughly. It's asking about how far will the ball fall in 3 seconds. Now, first thing we see is that it asks us to neglect air resistance. This means we're going to go ahead and just ignore that. We don't need that information. Okay? For this equation, you're going to need delta x, which in this situation will be the change in distance, equals initial velocity multiplied by the time plus 1/2 acceleration multiplied by time squared. So for all that refers to an object sort of just being dropped from Earth, you're going to assume that A equals 10 meters per second. That's just when an object is free fall, the acceleration is always 10 meters per second. So we're going to go ahead and fill in what we already have for this equation. For initial velocity, we know that the ball was originally at rest, making the initial velocity 0. Time is given to us in the question, 3 seconds. Acceleration, like I told you, is always going to be 10. And again, time is given to us. Don't forget that it's squared. Looking at this, I already see that I'll be able to go ahead and cross out the 0 times 3. And because of that, anything times 0 is 0, so we really won't have to worry about it. For this half, though, we will have to worry about it. 3 squared is 9, multiplied by 10 times 1/2. So, obviously, if I just given you this part, you guys probably could have all figured it out fairly quickly. But I'm just going to go ahead and work through it, just in case you ask me. Okay? So 10 times 9 is 90. Times 1/2, which equals 45 meters. Now, to multiply 10 times 9 first, you could have gone either way. If you had done 1/2 times 10, you would have gotten 5 times 9, which still would have been 45. Right? So the answer for about how far will the ball fall in 3 seconds is 45. just a simple choice. The same ball drops from rest by free fall acceleration is 1/6 with the ball on the moon ball or multiple egg 1/6 as far as the 1/36 as the ball on Earth, same distance as on Earth, 6 times as far as the ball on Earth, 8 as far as the ball on Earth. So, if we think back to what our equation is, delta x equals the initial velocity multiplied by time plus 1/2 acceleration multiplied by time squared. Alright, so the question is where the free fall acceleration is 1/6 time on Earth. So the only thing being altered in this equation is acceleration. If we change this, what happens? I want you guys to go ahead and pause it right here. I want you guys to guess what your answer choice is. Alright, so for those of you who guessed or know why, the answer choice is A. The reason for that is because the acceleration as squared or under a square root, then the actual constant doesn't change. The only thing that's affected is that 10 is multiplied by 1/6. So it'll be 1/6 as far as the ball on Earth. And if you want to further clarify, you can go ahead and plug in the others and do it. A big factor of this is the fact that this will be excluded because the velocity was 0. So you'd only be focusing on this. Alright. Alright. So if you got any questions, go ahead and email me. Any go ahead and see if you out. Talk really slow. Plus, big audio problem. I can only talk this slowly, understandable. And I was running right. Good luck on the test, guys.